Hi, welcome to another set of video notes. Today we're going to take notes on velocity and vectors by writing down ECQs and also completing our notes. Number 1, remember to highlight, so you may use highlighters, take out 2 or 3. You do not have to answer the ECQs yet, just copy them down. We'll be answering them in class. And number 3, you can pause, rewind, and replay any part of the video during this note-taking session. Alright, let's begin. Title OP47 of your science notebook, Velocity and Vectors ECQs. We have 3 ECQ questions, and remember to leave space between each question. Number 1, describe the main difference between speed and velocity. Number 2, explain why velocity is a vector. And number 3, list the 4 ways in which the velocity of an object can change. Pause and write if you need to. Your ECQ answers go on IP47 of your science notebook, so title this ECQ Answers. You can prepare answers by numbering 1 to 3 on your paper. Leave spaces between each number. It says each on there twice, sorry. And use complete sentences to answer your questions. Of course, we'll be answering in class, not right now. And pause and write if you need to. Alright, for your notes today, you can set up a key if you like. Remember, you'll need a highlighter for vocabulary, definitions, and also facts, any key facts from your notes. Page IP48. These are for your velocity and vectors note, so title that on the top of your notes page. On the bottom of this slide are the California state standards. The state of California would like to make sure that all 8th grade students know how the velocity of an object must be described by specifying both the speed and direction of the object. You should also know the changes in velocity may be due to changes in speed, direction, or both. And we'll talk about that during our notes. Alright, velocity is defined as speed in a specific direction. In other words, velocity is just like speed, but with direction. We've already learned that speed is distance over time, so with direction that can include north, south, east, west, left, right, and so on. An example, and this is not in your notes, but this is just an example for you, to remind you that velocity has direction, speed does not. So for example, if the police are dispatched to chase robbers that were getting away in a car, and are told that the getaway car was speeding at 100 miles per hour on the 91 freeway, what else do they need to know? If the police want to catch the robbers, they also have to know the direction that the getaway car is moving. In other words, 91 east or 91 west. If they take the wrong direction, the cops will never ever get the robbers, So velocity is actually very important because it includes direction, not just how fast an object is going. So let's try some questions to practice, review what we just studied. Number 1, what is the difference between speed and velocity? Go ahead and pause this and answer that question. To help you out, the answer is velocity includes direction. Speed does not have direction. Speed is just how fast something is moving, So check your answer. If it doesn't include any part of this answer, include it on your notes. Number 2, try this out. What is the velocity of a car that drives east for 2 hours at a steady speed of 50 kilometers per hour? Think carefully. Your answer should have just the speed and just the direction. And here's a hint. You don't have to calculate anything at all. Got it? Okay, go ahead and answer that question. Your answer should be 50 kilometers east. 50 kilometers per hour, that was the speed, and east is the direction. That's speed right here on this side, 50 kilometers per hour. East on this side is a direction. So you put them together and that makes the velocity. Now try this. Number 3, which of these has the greatest velocity? And you have this question on your paper. A cheetah running north at 30 meters per second. B, a balloon rising upward at 20 meters per second. C, a truck driving south at 35 meters per second. Or D, a person walking northeast at 3 meters per second. Go ahead and pause to answer your question. The answer is C, a truck driving south at 35 meters per second. That was the one with the highest speed, and since velocity and speed are pretty much the same, you'd look for that answer. Of course, this also includes direction, so that's why it's called velocity and not just speed. Number 4. A balloon moves upward a distance of 4 meters in 2 seconds. What is the balloon's velocity? Here's a hint. Solve for speed and add direction for your answer. Go ahead and pause and write your answer down. The answer should be 2 meters per second upwards, because what you had to do was take distance divided by time, 4 meters divided by 2 seconds. That should give you 2 meters per second. And then you include upward as a direction. So you have speed and direction. Number 5. Which of the following pairs has the same velocity? Now remember, velocity is speed and direction. So look at all answer choices A, B, C, D and see which one has the same direction and the same speed. A dog running south at 2 meters per second and a ball rolling south at 2 meters per second. Or is it B, a dog running south at 2 meters per second and a man running north at 3 meters per second? C, a kite moving east at 3 meters per second and a man running north at 3 meters per second? Or D, a ball rolling south at 2 meters per second and a kite moving east at 3 meters per second? Go ahead and make your answer choice. We'll pause this right now for you to do that first. You can check your answer later. The only one that had both velocities that were the same were the ones with both directions and speed is the same. So the answer would be A. Number 6. Monarch butterflies fly at average speeds between 1 and 2 miles per hour. Which would be the most likely velocity for a monarch on its migration from Canada to Mexico? Okay. A, 1.5 miles per hour. B, 1.5 miles per hour to the south. C, 16 miles per hour. Or D, 16 miles per hour to the south. Choose the best answer that has both speed and direction. Pause now and answer. Your answer should be B, 1.5 miles per hour, that's the speed part, to the south, and that's the direction part. Okay. Number 7. Car 1 is headed east at 50 miles per hour and car 2 is headed west at 50 miles per hour. Do they have the same speed and do they have the same velocity? Go ahead and pause and make your answers now. For A, yes, they do both have the same speed. They're both traveling at 50 miles per hour. But for B, no, they're heading in different directions. Let me move this down a little bit. So they have different velocities. Remember, if their directions are different, their velocities are also different. All right? That's very important. So they do not have the same velocity. Now, one of my favorite games, how does velocity change when you're moving in a circle? So if you're going around and around in a circle, how can velocity change? When you're moving in a circle, your direction is constantly changing. Therefore, your velocity is constantly changing. Because your direction changes from left, right, backwards, forwards, you're always changing your velocity. Another thing that you might have also thought of is your speed can change when you go in circles. If you've ever played Mario Kart, you know that you can speed up, slow down. When you go in a circle, right, you might drift a little bit. You're changing your speed as you go all the way around also. So velocity can change when you speed up, when you slow down, when you change direction, or when you change your speeds and direction together. By the way, that's your answer for ECQ number 3, right? It can change in 4 ways, right? So it can change by speeding up, slowing down, changing direction, or doing both of those, changing speeds and direction. All right, let's go ahead to the next one. Velocity is also a vector. You might have heard this word vector in math. A vector is any quantity that has both size, and scientifically we say magnitude for size, and direction. Vectors are usually shown as arrows to show how something is moving. So for example, in this picture, there's a light, right, moving to the left. And these little vector arrows, for example, show that it's going to the left, right? And that shows you that it has a direction. Okay. Your vector arrows shows you the way an arrow, let me repeat that. The way an arrow points shows the direction of velocity, so that's obvious. The length of the arrow, though, shows the size or magnitude of velocity. So a bigger arrow means that it's moving at a faster speed. A smaller arrow, like these little ones, show that it's moving slower, but it's going in that direction. So practice with vectors. In the following, explain if the speeds are the same or different, and then explain if the velocities are the same or different. So let me go ahead and pause and let you answer that. Speeds are both 10 meters per second. Directions are both north-east. Since both speeds and directions are the same, the velocities of both are the same too. Okay. Number 2, try it again. Pause and answer. Here's your answer. Try number 3. Pause and answer. Go ahead and check your answers. Okay. And number 4. Pause and answer. And go ahead and check your answer. Okay. Now, what I'd like you to do on page OP47, actually it should be OP48, so I'm going to try and fix that. Let me do that right now. OP48, because our notes are on page 48. There, that's fixed. Go back to the end. Almost there. Sometimes this happens. Up. Alright. Title page OP48, Review Questions, Velocity and Vectors. There are 6 questions at the bottom of your notes, so you don't have to write them down, but you will need to answer these 6 questions on the left side of your notes. Okay? So, title OP48 as Review Questions, Velocity and Vectors. Write 1 through 6, leave some space, and go ahead and answer these using your notes to help. Alright? I don't have answers for you on this one. I'd like you to use your notes to help me on this one. Alright? You can always go back, rewind, review, replay to help find the answers if you want to listen to it or read your notes and check. By the way, if you have not highlighted anything in your notes, go back, highlight keywords, definitions, and any important facts. Alright? That's it. Thank you, and I'll see you in class. Have a great day.